I wanted to give you guys some examples to use Excel this week for your week 6 lab assignment, and that way you can use Excel and have something that will help you see what formulas and so forth that you need to use. So what I did was I found an example where my X values are the amount of a ticket when it's purchased 30 days in advance, and my Y values are the cost of the ticket if it's purchased with a 1-day notice. So we're going to go through and find the scatter plot, correlation coefficient, and the regression line so that we can predict values. The first thing that I do for the scatter plot is I highlight the two columns with just the numbers. And then we go up here to insert, and we want to insert a scatter plot. So we pick the first one, and when I do that, it drops this beautiful graph in here. And if it's in your way, then you can move over to where you get the crossbars and then just slide the scatter plot over. And this kind of looks like an outlier, so if you don't like it, you can click on that and delete it. And now you can see that if we were to take a ruler, that yes, these points would form a linear regression, but we want to measure the strength of that. So our next point is to find the correlation coefficient. So over here you could just type so you know what you're looking at, because you know that you're going to have to put this in the Word document. And I pick a cell outside everything else. I go up here to formulas. Under more functions and statistical, I choose the abbreviation for correlation. And the first part that it asks for is the first array. So you highlight the first column values, and it automatically populates into there. For the second array, I need to move my cursor, and then again I'm just going to highlight those numbers. And when I hit OK, it gives me the correlation coefficient R, which we would round to probably 2 or 3 decimal places, and it's not strong, but it's not weak. So it's a good assumption to say that these two are related to each other, that there is a relationship. So now we want to know the linear regression equation. So without using the add-ins, what I'm going to do for a linear regression equation, because it's in the form y equals mx plus b, where m is our slope and b is the y-intercept. So first I want to find the slope. So I go to more functions, statistical, and again I'm just going to scroll down until I see slope. And the y's, notice that it puts the y's first, so you want to put those first. And I hit enter instead of tab. Helps if I make mistakes so you know that I'm human, right? Alright, so for the slope we're going to highlight the y's, and then I'm going to hit tab, and then for my x's, and then once they're in there we hit OK, and it gives me the slope. Again, you would want to put that at 2 or 3 decimal places. So you can either do it yourself or just go up here to the reduce decimals. Okay, now I need the intercept. So again, I go up here to formulas, statistical, and we're going to ask for the intercept. Notice again it puts the y's first. I hit tab, I highlight my x's, and I hit enter, and I get the intercept. Again, way too big, so we're going to drop that down to 2 decimal places. So that means that my linear equation is y equals negative 1,237 and 63 hundredths plus 7.073x for the unknown. So let's say we want to predict 30 days. That you want to predict how much a ticket is, predict a 1-day cost. If it's $300 when purchased at 30 days. So for Excel, what you can do is you want to hit your equals first so that Excel knows that you're putting in a formula, and then you're just going to type in your equation without the y, obviously, negative 1237.63 plus 7.073, and in parentheses type in the 300, or tell it that you're multiplying it times 300. And then you get the cost is $884.27 for a 1-day notice on a ticket that would cost $300 if you gave them 30 days notice. So I hope this helps with the first part of your lab. For the second part, you have to find confidence intervals. So without adding more things to your Excel, the easiest way to do this is to just use the confidence feature. So what we do in this case, I'm going to tell you that I have my sample size is 40. I have a mean of 2.1, and my standard deviation is 4.8. And I want a confidence interval with 99% confidence. So all I have to do is pick a cell, and we go up to formulas, functions, statistical, and you have this confidence. What it's going to do is give you back that error amount. Now alpha is your significance level, not your confidence level. So my confidence level is 99%, which means that left over I have 1%. So that's what my alpha would be. My standard deviation is 4.8, and we said our size was 40. So this gives me back the amount that I'm going to add or subtract from my mean. So the first thing that you do is your mean is 2.1. So again, I hit equals to let the computer or Excel know that it's a formula, and we're going to do 2.1 minus, and I can just move using my arrows, I can highlight that one, and when I hit enter, it automatically drops that number in. And then we want to do 2.1 plus for the other end of our interval. And so you would say that your confidence interval would be from 0.15, if we're just going to use 2 decimal places, to 4.05. So I hope this helps. You don't have to use Excel for the intervals. You can use your calculators. Same with the regression lines, you can use your calculators. But if you want to be more comfortable with Excel, then this is a way to do it.